In 2009 Form B question 1, we have the area under this curve here, which is 20 sine of pi x over 30. And we're going to use that area as the base of a cake. So we're not going to spin this around just yet, or at all, but we're going to use that as the base of the cake there. Alright, and what we want to do is create some kind of a cardboard foundation for the cake, and that region R is going to be cut out of a 30 centimeter by 20 centimeter rectangular sheet of cardboard, and the remaining cardboard discarded. So we want to find the area of the discarded cardboard. So in essence, we're looking for the shaded area of that rectangle there, and that's just going to be the area of the whole rectangle, which is 20 by 30, or 600 minus the integral, or minus the area under the curve, which is the integral from 0 to 30 of f of x. So then the area is 600 minus the integral from 0 to 30 of f of x dx. And we use our calculator, and here I have that function entered as y1. If I wanted to see it, I would need to set up my calculator window to be exactly the same as the graph on the screen. So I'd go to Window, and I have it here already, from 0 to 30 for x by 5s, from 0 to 20 for y by 4, and I go over and graph, and I already had that integral showing up from before. Now it's cleared out, so I'm simply going to second calc 7. I'm going to go from 0 for my lower limit up to 30 for my upper limit, and presto, I get 381.971. Now if I wanted to store that amount without writing it down, I could simply hit store and put that area into the variable a, and I would get 381.971, etc. And now 600 minus a would give me 218.028. In this case, they don't ask for units, but you should always get in the habit of putting the units there when they're given. Alright, we'll go on to part B. In part B now, we're going to use the base R as well, the cake is going to be a solid with a base of R. So R is going to be the base of the cake, and cross sections of the cake perpendicular to the x-axis are going to be semicircles. Kind of like what I've tried to draw into the original diagram there. So the area of each of those semicircular discs, well, the area of a whole circle would be pi r squared, half a circle would be pi r squared over 2, but in this case the radius is half of the height of the function. So don't forget that the radius is not the entire height of the function, that would be the diameter. Alright, so we're basically ready to set up our integral. We can bring out the pi over 2, integral from 0 to 30, f of x over 2 quantity squared, because that whole thing is my radius, and dx. Alright, now if I were solving this by hand, I probably would want to square the denominator of the radicand of the integrand, and so that would be 4, and then move it outside, so it would really be pi over 8 integral 0 to 30 of f of x quantity squared dx. So if I'm going to do this on my calculator, all I really need to do now is square the f of x that I have. So I go back into y1 and vars, y vars, function y1, square it. Now I'm going to either have to put the pi over 8 into that expression or multiply it by that afterwards. So I'll do it afterwards here. I'm just going to go ahead and graph. Now if the original graph is still showing up there, you can hit second and draw and clear draw, and that will wipe out the first one. Now we still have the other function showing up there, and the way we get rid of that is go into y1 and turn that one off. Alright, one more time. And finally we're going to find that area from 0 to 30, which isn't even 6,000. We store that in A, multiply by pi over 8, and we get 2, 3,